These are cheatable problems, but we're not going to do that. We're just going to check our answers because we're learning. Okay. Oh, crap, I forgot. All righty.
Really? Do you have to re-ink your stamps?
Oh, yeah.
Oh, you do?
It gets all over my hands every time. Miss Rice does it, doesn't get on her hands at all. I'm just like a toddler. Okay, so 2 pi over 3, 0, 3 pi over 3, 6 pi over 3. Okay, so far, does that make sense? Okay, now I'm going to look at the angle I have. It's 2 pi over 3. Is that going to live in the top half or bottom half?
Oh. Oh.
Okay, so it's going to live in the top half. So I'm going to cut the top half of my circle into thirds. And over here, I'm going to say 180 divided into thirds is 60. So I'm going to make these into 60-degree pizza slices. Thirds. Connor, think of it this way. 1/3, 2/3. You got to ignore this line. 1/3, 2/3, 3/3. Yeah. No, just ignore this. I mean the whole top of the circle I split into 3 equal pieces. So imagine that this line isn't there.
Wait, so would it be like the second line or would it be that full like thing?
So 1/3,
Oh.
2/3, 3/3. Don't, it's okay. We're learning. Okay, but the point of me doing that is visualizing 60, but it's also because I know that this is going to be a 30, 60, 90 triangle. So my next step is to figure out the reference angle and label the 30, 60, 90 triangle. My reference angle is going to be the difference between these two. So 3 pi over 3 minus 2 pi over 3 is 1 pi over 3. And pi over 3 and 60 are the same thing. Yeah, I did that just to cut my pieces into equal 60-degree. I wanted them to look like they were, each of my pieces were 60 degrees.
Oh, so you can do that if the numerator is greater than or less than the denominator? And you can always do that.
You can always do it. Doesn't have to matter what the numerator is. I'm going to do it again in number 4.
So you'd have to do 360, right? No? So I think it's like already past 180. You'd have to.
That's why I ask you if it lives in the top half of the circle or the bottom half of the circle, because I'm only dealing with half the circle, which is 180. Okay, no, all good. So if I go to my 60-degree triangle that I taped to my unit circle here, I notice that the short side is 1/2, and this is quadrant 2, so I want to be really careful and label that -1/2. And my long side is √3 over 2, and my hypotenuse is 1. So short side, long side, hypotenuse. Because I was just looking at the top half of the circle because I wanted to find this is 1 pi over 3, 2 pi over 3, 3 pi over 3. So I wanted to split it into 3 equal pieces. Okay. And last thing, the coordinate is back and up. So -1/2 positive √3/2. And now I'm going to look at the unit circle to check my answer. So I'm going to find 2π/3. He lives over here. Coordinate -1/2 positive √3/2. I am a genius. Okay. I love all the questions that you guys asked in number 3. Let's see if they make sense in number 4. So 0, 4π/4, 8π/4. Okay, with me so far? Yes? Okay. Now, 7π/4, is that going to live in the top half or the bottom half? Bottom. Yep, beautiful. Okay, so I'm going to go 180 divided by 4 is 45. I'm going to split the bottom of the circle up into 45-degree pieces. That doesn't look like 45. Forty-five, 45, 45-ish. Those are not perfect. It's fine. It's fine. It's totally okay. So you got to pretend with my little bit of wonky lines here that that's 45, that's 45, that's 45, and that's 45. Okay. Now if 4π/4 is here, this is 5π/4, 6π/4, 7π/4. And the reference angle is going to be the difference between the two of those. So 8π/4 minus 7π/4 is 1π/4. What's π/4 in degrees? 45. All right, we already found it down here. Nice. You guys are getting it. Okay. So there's my triangle. I'm going to find my 45, 45, 90. Gosh, that does not look like a 45, 45, 90, but that is okay. I'm just going to move on with my life. So both of the legs are √2/2. But this one I have to be careful is negative because it's going down. And the hypotenuse is 1.
Maybe I can remember that like the 2002 is like 30, 60, 90. Or the 45, 45, 90. 206. Is that gonna be like on the test or quiz again?
Okay, it is not on your quiz today. You do need to know it, but you can have a note card for your test.
Yeah.
So I would suggest drawing these triangles on your note card.
Okay.
Why is that?
I don't know, I'm a little bit confused too, like,
Okay. So coordinate is forward and down. Now, when you take pre-calc, if and when you take pre-calc, they do expect you to memorize that. They expect you to memorize the first quadrant and then be able to apply that to the other 3 quadrants according to the signs. In math 3, we don't really, we're learning. I have a feeling though, that by the end of this worksheet, most of you will have it memorized, whether you like it or not. Okay, so next, can you guys go back into your notebook? This is going to be a little blast from the past and find these 3 problems, 37 through 39. For our classwork today, we're doing a resource page, but we need to add a little bit to 37 and 39 so that it makes sense. So just search back through your notebook for the problems 37 through 41. They should be the first three. 37 through 41 would be the title. Okay, and today is the very one day we're going to spend on tangent. We're gonna graph tangent, we're gonna look at what tangent looks like. We only spend one day on tangent. I will never ask you to graph tangent on a quiz or test. Do I expect you to know what it looks like? Yes. Do I expect you to have a very basic understanding of it? Yes. This will be mostly applied in our class to Pythagorean identity problems, not waves functions. So anyway, we spend one day on it. It's going to be number 84, which is the investigation of the tangent function, and then we have our quiz.
Study.
Good, good. Okay. Homework is unusually 5 problems, but on Tuesday it's only 3 problems, so I balanced it out that way. This is my joke. Teacher, where is your homework? Me, I lost it fighting this kid who said you weren't the best teacher in school. Yeah, I feel like Connor would do that for me. Okay. All right. Okay. So adding to this circle 37, I'm going to take my pen. I'm going to write this. I'm going to go with dark green because I want it to show that it's a different lesson, but it really shouldn't be that different. Anywhere that you have space, write tan 34. Okay, now we know that tan 34 is something we could type in the calculator. I'm not interested in that. What I'm interested in is you guys remembering TOA. Okay, you guys all know what TOA is. Beautiful. Okay, so up here, I'm going to write TOA. And then I want you guys to tell me what the opposite is in this triangle and what's the adjacent. Y over X. Okay, tangent is Y over X, which is the slope. And you learned that in math too. You learned that tangent was the slope. You actually learned tangent first if you took math 2 in our school. Okay, and so for us, what I want you to notice is that the y is the sine. And the x is the cosine. Do you guys all have that? I need you to know y is sine, x is cosine. That's very important. Okay, so now let's go to the calculator, just see if Mrs. Talbot's making stuff up over here. Sine, oh, I don't need to do that. It's right here, but tan of 34. Okay, so I'm in radians. I'm in radians. I'm in radians. Tan of 34 is this. Okay, so what I'm suggesting is that this decimal should be the same thing as when I put sine of 34 over cosine of 34. Let's see if I'm making up crazy math over here. Oh man, I am a genius. Okay, so that is 0.559 divided by 0.829, which is 0.675. Okay, now we're going to come down to number 39. And we're going to add tangent here. Tangent What's wrong, honey? I'm sorry, what? This is all we're adding right here. It's done. We're done with the notebook now. So if you could just squeeze that in. We're not doing any more. We're just doing a little definition of tangent. A little adding of what that is so that now it's complete. You have cosine, sine, and tangent all on the same spot. Yeah, just, throw it in the margins, whatever you can do. Okay, now after you have that, I need you to find the tangent resource page, which I believe says, uh, it says, it says, it says something. It says, oh my gosh, this package is what it says. It says 9.1.7 resource page. Okay. All right, the first thing we're going to do is fill in these two columns off of our unit circle. So remember, cosine is the x, sine is the y. So at 0, 1, 0. Pi over 6. Pi over 4. Pi over 3. Thank you. What's happening? Coughing. Whatever. I'm fine. I'm totally okay. Pilot is flying the plane just fine over here. Don't you worry. Okay, so I really didn't do anything spectacular there. I just copied the coordinates off my unit circle. Okay, now we're going to find the tan exact and approximate. You're going to feel like this is going to be a lot of work, but just like all the other math we do, we establish a pattern. We won't have to do all of this. Okay, so I want to remind you that tan is y over x. So write that up here. So this one is 0 divided by 1, which is 0. Woohoo! Okay, they're not all going to be that great. Okay, pi over 6 is where the worst one, probably of all of them. Okay, so sine over cosine. Sine over cosine. I just wrote it like this type of fraction because of the space that I have in this thing. Okay, so now I'm going to remind you of keep, change, flip. Keep, change, flip. So I kept the first fraction, changed it to times, flip the second one. Okay, now I can cancel out the 2's, and I have 1 over root 3. However, Yeah, you already see it coming. Don't worry, this is the only time we have to do this today. Okay, so the exact is root 3 over 3. And then I'm going to go on the calculator and do, you don't have to do this, 0.577. Okay, next one. Y over X. What do you get when you have the same thing on the top and the bottom of a fraction?
Big one.
Excellent. One, one. Moving up. Y over X. Keep, change, please stop that. Flip. I love this problem because the 2's cancel and the root 3 is on the top, so I don't have to rationalize. That's just how lazy I am. Okay, and now we're going to start to see the pattern after this. This one, though, is weird. Y over X is not 0, it is undefined. Y over X. Which problem is this one exactly like? Which one goes with 2 pi over 3? Almost exactly the same problem. Pi over 3, right? Okay, so what we can do is just copy off the answer, but make it negative because one of the fractions is negative. Y over X. Okay, what's the answer to this thing? Close. Beautiful. Y. Why is this so hard for me to write? Okay, now which problem is this one like? This guy, right? Almost exactly the same, so we just go negative root 3 over 3. Y over X. Y over X. These two are the same, but now I have two negatives, which make it a positive. Okay. Now we're going to plot these points down here. We hope they. Talbot, yes.
Yeah, I was wondering.
What? We are. We're going to graph tan now. Okay, so this first line is 0, 0. So I'm going to look at the very start of the table and the very end of the table. It's for the coordinates. So 0, 0 is my first one. Pi over 6, 0.577. Pi over 6, 0.577. Pi over 4, 1. Pi over 4 lives right there. Pi over 3, 1.732. pi over 2 is undefined. Okay, what do we do when something's undefined in the rest of our math? It starts with an A and ends with a asymptote. Asymptote. Okay, so you guys are going to draw an asymptote here. Okay, 2 pi over 3 is negative 1.7. 3 pi over 4 is negative 1. That lives right between the two that you have labeled. 5 pi over 6 is negative 0.577. I made this too little. And pi is 0. And 7 pi over 6 is positive 0.577. Okay, and now what I'm going to do is I'm going to go back to radians on my calculator. And I'm going to show you what this looks like so you can sketch it in. Tangent looks like a bunch of repeating cubics. Okay, so the asymptote is between, so this is going to go like this right here. Where's the next asymptote going to be? Okay. For time purposes, we're going to answer the rest of this very quickly. What this, by the way, repeats on forever. You can fill it in if you like. We do not have time. Where is tan greater than 0 and where is it less than 0? This question I care more about on my unit circle than I do here. But what quadrant is this quadrant right here? Quadrant 1. And what quadrant is this? 2. And what quadrant is this? 3. And quadrant 4 will be negative. Okay, so tan is positive in quadrants 1 and 3 and negative in quadrant 2 and 4. So what I want you to do is if you have your unit circle out, add positive tan here, negative tan here, positive tan here, negative tan here. Mhm. 3 pi over 2. I just counted the boxes. Okay, where is tan plus or minus 1? Every what? Every what? Look back at the table. Where is tan plus or minus 1? Okay, so every 45 degrees in the middle of each quadrant, tan is 1. Some of my students like to go back and put the tangents in the unit circle. I'm not going to do that, but you can if you want to. Where is tan 0? 0, pi. Where else do you think? What's the 2 pi? Great. Dot, dot, dot forever. Where is tan undefined? Pi over 2, 3 pi over 2. Dot, dot, dot forever, which is up here and down here. Alrighty. Put everything away, my dears. It is quiz time.